In optics, the Airy disk and Airy pattern are descriptions of the best focus spot of light that a perfect lens with a circular aperture can make, limited by the diffraction of light. The Airy disk is of importance in physics, optics, and astronomy. The diffraction pattern resulting from a uniformly illuminated circular aperture has a bright region in the center, known as the Airy disk, which together with the series of concentric bright rings around is called the Airy pattern. Both are named after George Biddle Airy. The disk and rings phenomenon had been known prior to Airy. John Herschel described the appearance of a bright star seen through a telescope under high magnification for an 1828 article on light for the Encyclopedia Metropolitana. The star is then seen as a perfectly round, well-defined planetary disk, surrounded by 2, 3, or more alternately dark and bright rings, which, if examined attentively, are seen to be slightly colored at their borders. They succeed each other nearly at equal intervals round the central disk. However, Airy wrote the first full theoretical treatment explaining the phenomenon. Mathematically, the diffraction pattern is characterized by the wavelength of light illuminating the circular aperture, and the aperture's size. The appearance of the diffraction pattern is additionally characterized by the sensitivity of the eye or the detector used to observe the pattern. The most important application of this concept is in cameras and telescopes. Due to diffraction, the smallest point to which a lens or mirror can focus a beam of light is the size of the Airy disk. Even if one were able to make a perfect lens, there is still a limit to the resolution of an image created by such a lens. An optical system in which the resolution is no longer limited by imperfections in the lenses but only by diffraction is said to be diffraction limited.